Hello everyone, this is Professor M. Kutwal, Department of Agronomy, College of Agriculture, Meresgaon. Today we discuss one of the important chapter, that is irrigation requirement and water requirement, net irrigation, gross irrigation, and interval of irrigation, and we discuss the methods of estimation of water requirement and factor affecting it. So firstly, we discussed what is meant by the irrigation. Irrigation defined as application of water to soil to assist in production of crops, especially during stress period. Water requirement is defined as the quantity of water required by a crop or a diversified pattern of crops in a given period of time for its normal growth at a place under field condition. Water requirement is therefore a demand and supply would consist of contribution from any of the source of water, the major source being the irrigation water. Indicate are effective rainfall and soil profile contribution like soil water and groundwater. So basically the formula of water requirement is indicated here. WR is equal to IR irrigation requirement plus effective rainfall plus soil profile contribution. This indicate here. The next one, the cross irrigation requirement. It refers to the amount of water applied to the field from start of land preparation to harvest of the crop, together with the water loss in convenience through distribution and field channels, and also during the irrigation to the field crops. So these are all losses comes under that. During the crop growing period, net irrigation are applied to replenish the soil water deficit. It is net irrigation requirement and water losses such as convenience, distribution and application. The net irrigation requirement is the amount of irrigation water just required to bring the soil moisture content in the root zone depth of the crop to field capacity. Thus, the net irrigation requirement is the difference between field capacity and soil moisture contained in the root zone before application of irrigation water. Determination of water requirement is essential to decide the possible cropping pattern in the farm or in a area. Second one, make effective use of available of water supplies under any season. Third, plan and design in an irrigation project. Then plan water resource development in an area. Then assess the irrigation requirement of the area and management of water supply from source. Then what is meant by the irrigation interval? The term of irrigation interval is the frequency of irrigation and interval of irrigation are closely related and are often interchangeable interchangeable with higher frequency of irrigation. The interval between two irrigation decide in a given period, while the lower frequency the interval between two irrigations increases. The term interval of irrigation indicates the time gap usually expressed in the days. between two subsequent irrigations. Basically, depletion irrigation interval is equal to available soil water divided by daily water use. Then we last point we discuss here the factor affecting interval or frequency of irrigation. First, the two main consideration in water need of a crop and the ability of irrigation decide the irrigation frequency. Once these two are known, the frequency of irrigation is influenced mainly by climatic and season. Second one, soil characteristics. Third, crop characteristics and crop and water management practices and irrigation period. Then we discuss the transpiration. What is meant by transpiration? This process by which water in plant body transferred to the atmosphere in the form of water vapor. So we call transpiration. Transpiration is the process by which water evaporates in the form of water vapor from living plant body, especially from leaves to atmosphere. The rate of transpiration depends on supply of energy to evaporate the water and the water vapor concentration gradient at atmosphere. It is further influenced by the climatic and soil and plant factors. Seasonal consumptive use. It is the total water requirement for the crop growing period to meet the evapotranspiration losses. Hence, it can be started as the total water used in evapotranspiration by cropped area during the entire growing season, which is called as seasonal consumptive use. It is expressed as depth of water in centimeter. Thus, value is used to evaluate and determine the seasonal irrigation water requirement. Seasonal consumptive use values are required to evaluate and determine the seasonal irrigation water supplies. Peak period consumptive use. The highest consumptive use for a certain period in the growing season is called the peak period consumptive use. Thus, value is used in the planning and designing of irrigation system. The peak period consumptive use will vary from soil to soil and from crop to crop. In the irrigation project design, this peak period consumptive use will be accounted for proper planning and use of the available water efficiency for different cropping pattern. Factors affecting water requirement of crops. Water requirement of crops vary from area and even from field to field on a farm. It is therefore not appropriate to make general statements of water requirement of a crop or specify the number of irrigations or irrigation interval for a crop. Instead, including the development states of crop phase, it is essential to give irrigation and avoid moisture trace is more meaningful. A. Crop factors. Variety of the same crop differ in duration, rooting pattern and canopy structure. The variety with longer duration obviously requires more water for consumption of the life cycle. Soil factors. Evaporation from soil differs due to their difference in hydraulic conductivity, reflectivity, and thermal conductivity. Climatic factors: lower rainfall, higher temperature, lower humidity, high wind velocity, higher solar radiation, higher adaptive energy result in higher evapotranspiration losses of water, but correspondingly lower values of afford size cause a lower water requirements. Crop management practices: all the management practices that provides favorable environment to the crops increases the leaf area and thus the increase evapotranspiration. Tillage practices influence rooting characteristics and thus influence evapotranspiration. Thank you.